How's it, guys? Welcome to the channel. My name is Sal and I identify as a globehead. To all the people who watch the videos, give the videos a like and leave comments, thank you so much. I really appreciate it. For the background of this video, I just put together some photos, live clips and time lapses of the sky at either dusk or dawn. Do you guys remember sometime last year when Daniel Pratt challenged Simon Dan to hover a helicopter above a roundabout and then wait for the ground to move away from under the helicopter? I got a similar kind of suggestion in the previous video, and I'm going to respond to some of his points from those comments in this video. It was a back and forth. He left a comment, I replied to the comment, and it was a back and forth until we got to the point where I told him, you know, the earth is in constant motion. It can never be as it was before. So his comeback was, oh, you're one of them people. Like thinking that the earth is in motion is like such a big sin or something. He says, well, drop a bucket of water on your head from 50 meters above the ground and tell me that the earth is moving. Okay, so first I laughed my head off because I have been learning more and more about how we count time. And for this little experiment, it is going to be imperative that I have to demonstrate what the hell is going to happen. So, as you guys know, I don't like maths. But for this one, I forced myself to try and find the answer. I needed to know, with the gravitational speed, how long will a bucket of water take to fall from 50 meters above the ground. Oh guys, while I'm recording this segment, it's raining, so if you hear the rain in the background, enjoy it. I am. The following are all the formulas and steps I've taken to make these calculations. Also, he didn't provide us with an amount, so I just used 7 liters, but actually the amount doesn't really matter. What matters with the amount is the energy at impact. The formula is height times 2 divided by the speed of gravity. So it's 100 meters divided by 9.8 meters per second squared. And we get the speed of impact at 31.30 meters per second or 112.70 kilometers per hour. And the time until impact is 3.19 seconds. Also, because I used the mass of 7 kilograms, we can calculate the energy of impact, and that will be 3,430 joules. So besides saying that just drop a bucket of water from 50 meters above your head, he doesn't give us any other information, and you can substitute whatever mass you want, right? But the gravitational speed is not going to change. It stays the same. So from 50 meters above the ground, however much water you are going to drop, it's still going to take 3.19 seconds to impact. So one thing I really want to explain is when I use dateandtime.com and I'm looking at where the sun is, its altitude and direction, actually I am measuring the rotation of the earth, how much the earth shifts in its rotation within a specified period of time. And here I've put together a tiny 6-second comparison between a day in June and a day in January. And you can see the shift for yourself there. It's a max of 0.02 degrees. So that is not enough time or height to get me away from the falling water unless I physically take a step away from it. But if we just want to measure the rotation of the earth, we just don't have enough height or time. And also a very important thing that these people seem to forget or maybe even ignore is that the earth is surrounded by a giant ocean of air. We call it the atmosphere. Speak to any photographer, even I can tell you. That's why I try not to zoom my camera, because it distorts, the air actually distorts the photography. So concerning that hovering chopper, and if I'm looking at it, that chopper is not going to go anywhere from my perspective unless an external force is exerted on it, which in the chopper's case is the pilot moving the stick shift. But otherwise, the perspective isn't going to change because the atmosphere, the helicopter, and me are all being dragged along with the earth in its rotation. And also another thing, we are so used to saying sunset or sunrise. It's almost imprinted in our brain, so we can almost be forgiven for thinking that, yes, the sun actually goes down below the horizon, or it actually comes up from below the horizon. But in reality, that is not what is happening. In reality, it's the earth in its rotation on its own axis, turning away or towards the sun. And now to address some final points that he made towards the end of his comments towards me. He said that I should change the name of the channel because I won't be able to convince anybody with my observations. And I have to politely decline. I am not changing the name of the channel because it is bang on what flat earthers say. They say the southern hemisphere does not exist, and they call us globeheads as an insult. And the second thing he suggested was I should stop doing what I'm doing. Here too, I will have to politely decline because this is when the fun begins. I have been making these observations for more than 2 years now. And what are some of flat earthers' mantras? Do your own research. Make repeatable observations. Well, with time, you can make repeatable observations, and I am now at that point where I can make these repeatable observations. Where was Sirius back last year in June to where it is now? Where was Canopus in October last year and where it is now? Where the sun set last year this time or 2 years ago this time? I can make all these repeatable observations and not forgetting the moon. Why in the world would I ever think to stop now? Guys, initially I wasn't going to do the calculations because from my observations of sunsets over and over and over and over, I learned to gauge the rotation of the earth within a few seconds period. And I knew this was going to take between 3 and 4 seconds. But then I thought to myself, oh man, this information is just literally a search away. You can do it. So I just did it. And just by doing this simple calculation, I have learned so much. For instance, all the formulas in this calculation is Newtonian physics. I didn't know that, but as I said, I thank flat earthers. I have learned so much by doing my own research. And as I wrap up this video, I'm not sure if you can hear the whistling wind and the rattling of the windows. There was a tropical storm that started off the coast of Madagascar and it worked its way across the Indian Ocean. And before it made landfall in Mozambique, it developed into a tropical cyclone. And now the remnants of that storm is moving across the northern interior of South Africa. It's one hell of a storm brewing. That's it for this video, guys. Thanks for watching. Please, guys, stay safe, and I'll catch you in the next video. Bye.